This lesson is on the difference between linear and nonlinear functions. A linear function is a function that has a constant rate of change or a constant slope. When you're determining a linear function or nonlinear function from a graph, a linear function will always be in a straight line. You can have a positive slope, it can have a negative slope, or it can have a slope of 0. A nonlinear function does not have a constant rate of change and is not going to be in the form of a line. A linear equation is always going to be in the form y equals mx plus b. M is the slope and the b is the y-intercept. In this case, the variable, the x, will always have an exponent of 1. So a linear function is an equation to the first degree. We want to determine if this table represents a linear function. In order for it to be a linear function, it has to have a constant rate of change. So I'm going to find the rate of change from each point. So I'm going to determine how the y's are changing and determine how the x's are changing. The x's are all increasing by 1. The y's, to go from 4 to 8, is increasing by 4. 8 to 12 is increasing by 4. 12 to 13 is increasing by 1. So I have to find my rate of change, or my slope, which is the change in y, over the change in x. So I look at each part, the slope here is 4 over 1, or 4. The slope for the second change, 4 over 1, or 4. And the slope for my third change is 1 over 1, or 1. Since my rate of change is not the same for the whole table, this is not a linear function. I want to determine if each of the graphs below represents a function. If it does, we have to state if it's linear or nonlinear. In order for a graph to be a function, it has to pass the vertical line test. That means that every vertical line can only touch my graph one time. So 1 here, this is a function because it passes the vertical line test. And since it's a straight line, it is a linear function. Graph 2 passes the vertical line test, so it is still a function. And even though this one part is a straight line, the other part is curved, so this would be a non-linear function. The third one also passes the vertical line test, so it is a function. And since it's curved, this would also be non-linear because it does not have a constant rate of change. Number 4, if I draw a vertical line here, touches my graph 2 times, so this one is not a function. Number 5, draw a vertical line, touches my graph 2 times, so number 5 is also not a function. And the last one passes the vertical line test, and it is a function. And even though it is made up of multiple lines, since it's not one singular straight line, this would be a non-linear function. Now, to determine if an equation is a linear function, remember it has to be in the form y equals mx plus b, and the x has to be to the first degree. So for number 1, I would divide everything by 5, have y equals 7 over 5x plus 6 over 5. My x is to the first degree, so this is a linear function. For number 2, it's already in y equals form. The x is to the 5th degree, so this is a non-linear linear function. Number 3, I can add x over 9 to both sides. I have y equals x over 9 plus 12. And I can rewrite this as y equals 1/9 x plus 12. Since my x is to the first degree, this is a linear function. And number 4, I have to add 11 to each side. When I add 11 to each side, I have 2x to the third power plus 11 equals y. The x is to the third power, so this would be a non-linear function. Any function to the third power is called a cubic function.